Hi everyone, in this video we're going to go over two applications of the double angle formula. The first is a direct application where we're just plugging into the formula. The second is how we can use it to solve a trig equation. So here are what the formulas say. They follow directly from the sum of angle formulas from the last video. So sine of 2 times an angle can be obtained by looking at 2 sine of that angle times cosine of that angle. And cosine of twice u, where u is our angle, is calculated by taking cosine squared of u minus sine squared of u. So here's an example where we're just going to directly plug into one of these equations. I want to find cosine of 2 theta if cosine of theta is 5 over 13 and theta is in quadrant 4. So I draw a picture. If my theta is in quadrant 4, then I've gone about this far, and the cosine, so I'm looking at this triangle here. If cosine's 5 over 13, then I know that this is 5 and the hypotenuse is 13. And I solve for the remaining side. That's 12, but since I'm in quadrant 4, I'm thinking of this as the point 5 comma negative 12. So when I calculate the sine of theta, I'll find that sine is negative 12 over 13. Now, why did I do that? Because the formula for cosine of 2 theta is cosine squared theta minus sine squared theta. So I needed sine of theta. So the cosine of theta is 5 over 13. So plugging into this formula, I'll do 5 over 13 squared. To get sine squared theta, I take sine of theta, so negative 12 over 13, and I'll square that. And the formula says I should take the difference between those two values. So what will I end up getting? Let's see here. 25 over 169 minus 144 over 169, which gives me negative 119 over 169. So that's just a basic application for plugging directly into this formula. We're given one piece of information, we're given the cosine of an angle, then we're able to find the cosine of twice that angle without even knowing what the angle was. So that's pretty neat. Now we'll go through an example where we solve a trig equation by using this double angle formula. So what I'm trying to solve is 2 cosine x plus sine 2x equals 0. So I can't use my normal strategies here because here I have x and here I have 2x. So what I need to do first is apply the sine of a double angle formula to this term, and then we'll be able to do some work towards solving this equation, the strategies that we're normally used to. So I'll rewrite this 2 cosine x term, but instead of the sine 2x term, I'm going to put in 2 sine of u, or 2 sine of x times cosine of x, by using this formula. The reason that that was helpful is because now I just have sine of x and cosine of x. This is the type of equation that we know how to solve. We can't combine a single angle and a double angle equation. We need to just have x, 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 or if these all said 2x, 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 that would also work. But we can't combine an x and a 2x. So now we'll use our normal strategies. We notice that there's a cosine x in the first term and the second term, so let's factor it out. And actually there's a 2 in each term, so I can factor out 2 cosine x. From the first term I'll be left with 1. From the second term I'll be left with sine of x, and the whole thing equals 0. So now I set my two equations, each equal to 0. So I have 2 cosine x equals 0, and 1 plus sine x equals 0. From the left-hand one, I learned that cosine x equals 0, and that means that x has to be pi over 2 or 3 pi over 2, because I'm thinking about the unit circle, cosine is 0 at each of those places. Solving the second equation, I see that sine of x must be -1. So again, going to the unit circle, sine is the y value, so sine is -1 when we're at 3 pi over 2. So x is 3 pi over 2. And that was a value that we already got. So our answer is x equals pi over 2, or 3 pi over 2. And so we couldn't solve the equation until we used the double angle formula, but then once we used the double angle formula, we had an equation which we knew how to solve using the strategies from the last section, just factoring, setting each of the factors equal to 0, and solving by using the unit circle. So hopefully this video was illuminating and will help you with the problems that you're working through, and let me know if you have any questions.